Hello, and welcome to tonight's broadcast. We are doing Algebra and Trigonometry, and now we're doing Chapter 1.4. The book we're using is part of the OpenStax initiative by Rice University. It's in the Creative Commons. So go in the description of the video and download a free copy. I have a physical copy, which is very nice. So I highly recommend you getting either digital, which is free, or buying the physical copy. And what happens is I'm going to do the reading, and then depending upon how far I get, then I will do the questions. So right now, let's just get right into it. Okay. So the reading is 1.4 polynomials. In this section, you identify degree and leading coefficient and subtract polynomials, multiply them, use FOIL to multiply binomials, perform operations with polynomials of several variables. Okay, Earl is building a doghouse whose front is in the shape of a square top with a triangle. All right. Okay, and this is going to be 32 feet. All right. 1 foot. This is x. This is 2x. He wants to find the area of the doghouse so he can purchase the correct amount of paint. Using measurements of the front of the house, we can create an expression that combines the variable terms, allowing us to solve problems like that. A is equal to s squared, which is equal to, now the area is base times height. So we this is a square, so we're gonna say this is also 2x basically. So then we have 2x squared, which comes to 4x squared, and this is gonna be the area of the square in square feet, and then the area of the triangle part over here is area half base times height, and then that's going to be 1/2 times 2x times 3/2. Okay? And that's because our width is 2x. That's where we're getting that from. All right? And so that, we're going to simplify, scratch that. So that's going to be 3/2x. Okay? Now, next we need to find the area of the regular door in square feet. So, area of the door, 1 foot, and this is x. So, area is equal to length times width, so which is equal to x times 1, which is equal to x. And square feet, x square feet. So now we're just going to write this all out. 4x squared plus 3/2x. And then we're going to say, now the door, remember, we're painting everything but the door. And that's going to be minus x. And this is going to be in feet squared. Okay, and now we could simplify this further. Since we have two x's of the like type, we're going to simplify this. It's going to be 4x squared plus 1/2 x feet squared. All right, so because that's 1.5 x and we're subtracting an x from it, so we get half x. In this section, we'll examine expressions such as this one, which combines several variable terms. Identifying the degree and leading coefficients of polynomials. All right, here we go. The formula just found is an example of a polynomial, which is a sum of or difference of terms, each consisting of a variable raised to a non-negative integer power. A number multiplied by a variable raised to an exponent, such as 384 pi, is known as a coefficient. Coefficients can be positive, negative, or zero. It can be whole numbers. So basically, 300. Let's see here. A number. This is going to be a variable multiplied by a. So I guess this is. Back here. All right. Coefficients can be positive, negative, or zero, and can be whole numbers, decimals, or fractions. Each product, such as a to the I or x I, such as 384 pi w, is a term of a polynomial. If a term does not contain a variable, it is called a constant. So, in other words, pi is a constant. Let's see here, 23 is a constant, 0.9 is a constant. These things, they have a set value, right? They can't be some assigned value that we don't know of. So x, y, z, these things are all variables. Okay. And all right, so we're going to say next, a polynomial containing only one term, such as 5x to the fourth power, is called a monomial, okay? And a polynomial containing two terms is called a binomial. So this is a monomial and binomial. Okay, a polynomial containing three terms, 3x squared plus 8x minus 7, trinomial. We call the degree of a polynomial by identifying the highest power of the variable that occurs in the polynomial. So, leading coefficient, we have our variable, and now the coefficient, in this case a, will be some constant number, right? And then the variable is the x. It can be anything, really. And this is n, this is our degree. And then plus plus a sub 2x squared plus a sub 1x plus a sub 0. And this is a sub n. So this is our leading term. Okay. And this is the form of the polynomial. Each real number, a sub 1, is called the coefficient. And now real number, again, is a constant number, right? And so that could be like pi, it could be 9, it could be 0.35, and so forth. A number a sub 0 that is not multiplied by a variable is called a constant. So there's no x's here, that's a constant. Constant. Each product of a sub 1 x to the I is called the term of a polynomial. So this is a term. And so is this. They're terms of polynomial. And the highest power of the variable that occurs is called the degree of the polynomial. And this is the n. The leading term is the term with the highest power, and its coefficient is called the leading coefficient. So a is the leading coefficient. X to the nth power, that is a leading term. Okay. All right. Now identifying the degree and the leading term of a coefficient. So let's just do some here. So we have 3 plus 2x squared minus 4x to the third power. Let's write them in order. In descending, 2x squared plus x to the 0 plus 3. By the way, this right here, this is something that I did in linear algebra. It's when you can always like you can anything times 0 is 0, right? But if you wanted to organize the polynomials, you don't have to put that in there. Just know that it exists in the sense that that's just like a spot, right? These things are descending like steps. N to the n minus 1 down to n minus 2. Then means eventually it's going to be 3x, then 2 x squared, and then x to the first power, then x to the 0th power. So in this case, x0 plus 3x to the 0th power. And this is x to the first power. Now, x to the 0th power, of course, that's 1 times 3. And 0 times x to whatever is 0. So this is, think of it as another way. These things are all there, even if it's not explicitly written out, right? All these things equate to this. That's all in there. Whether or not you choose to write them, it's up to you, but all those things are existing in there. The x to the 0th power is there. The x to the first power times 0 is there. They're in the sense that by the structure that I set it up, this is an ordered structure in that sense, and the numbers, the values remain the same because of, if you're going to choose to plug those in, you have to be very careful and know what to plug in. If it's not explicitly listed that there's an x to the first power or there's an x there, you could write one in, but you have to put a 0 next to it. So that gets rid of it in that sense. Okay, so anyway, we wrote this out in order. And now, let's see. The leading degree is going to be, this is going to be 3. So the highest power is 3, the degree is 3. The leading term is right here, because we wrote it in order. And the leading coefficient, this is our leading coefficient. Okay, so what is the highest power is 3, so the degree is 3 of our polynomial. This is a polynomial of degree 3. Okay, and next we have now poly means many, by the way. So we have a polynomial of degree 3 with a leading coefficient of 4 and a leading term. So basically, degree 3 -4 leading term of -4x to the third power. Okay, and so we have polynomial degree 3, a leading coefficient of -4, and leading term of -4x to the third power. Okay. All right, now let's do another one. All right, we have 5t to the 5th power minus 2t to the 3rd power plus 7t. This is also equivalent. They gave this in order, by the way. And plus 0t to the 4th power minus 2t to the 3rd power, and then plus 0t squared plus 7t. Wait a minute. 7, sorry, I didn't write that right. That's just t. T plus 7, t to the 1st power plus 0 t to the 0th power. Okay, so notice I put that one in, that one in, that one in. They all equate to 0. But if I wanted to organize it in an order from our n all the way down to 0, our powers, you can do that. You don't have to do that. And again, this is more convenient when you're adding multiple polynomials together, and that's why you're going to put those zeros in. You do it a lot in linear algebra, but in this case, it's not necessary. So our leading term is 5t to the 5th power leading coefficient is 5, and our, what was the last question? Degree is 5. Okay, so this is our degree, this is our leading coefficient, and this is our leading term. All right? So the highest power of t is 5, degree is 5, and we have the degree. Okay, that's good. All right, next we have 6p minus p to the 3rd power minus 2. Let's write this in order. Negative p to the 3rd power plus 6p minus 2. So we're going to have a leading term is negative p to the 3rd power. And then we're going to say our leading coefficient is negative 1. So the negative p is also negative 1 times p to the 3rd power. That's fine, same thing. And then we're going to have our, what is the question? Let's see, the power, so degree. Degree is 3. Okay. Yep. All right, so that's good. And one more we have here. All right, so we have 4x squared minus x to the 6th power plus 2x minus 6. Let's write this in order. Negative x to the 6th power. So in this case, yeah, plus 4x squared plus 2x. We fundamentally just want to know about this position, right? I don't have to rewrite the whole thing, but that's fine. So we're going to say leading term. We identify that, and then we take the elements. Negative 6x, or negative x to the 6th power. And then we're going to say leading coefficient is going to be negative 1. And then we're going to say, and the degree is 6. All right. So hopefully all that makes sense. This is a try it, so then we have to go and check it, of course. But yeah, this is pretty straightforward. Here we go. Try it answers. Yes, degree is 6. A leading term is negative x to the 6th power, and leading coefficient is negative 1. Okay, good. I'm going to mark the try it section so I can access that also as necessary. Okay. Next. Adding and subtracting polynomials. We can add and subtract polynomials by combining like terms. which are terms that contain the same variables raised to the same exponents. For example, 5x squared and negative 2x squared are like terms that can be added. Weren't we already doing this? We were doing, yeah, we've already been doing this. I don't know why they're going over it now, but it's fine. Because this is already stuff we've been doing since the last chapter. Anyway, yeah, adding like terms and subtracting like terms. Let's just do that real quick. All right. So we have 12x squared. I'm going to show you something straight out of linear algebra. And you're going to understand why I've been putting those zeros there. X squared minus 5 plus 20. Now, you can do it like that. That's totally fine, right? You can just go over and carry them over. You could also write them differently. You can do this. You're going to say 0x to the third power plus 12x squared plus 9x minus 21. And then we're going to say plus 4x to the third power plus 8x squared minus 5x plus 20. This kind of addition, now, when we do it with a linear algebra, we would use a slightly different method, but the idea is essentially the same here, right? There we use a matrix. A matrix is like bars like this, basically. But this is fine. This works just as well. So then we're going to add plus 20x squared, and then plus 4x minus 1. Okay? And if you look at the answer, that is correct. But what I've been trying to tell you is that it's not for no reason that I'm putting the 0x and organizing them stepwise. If you have to do a lot of addition and subtraction, like in linear algebra, it makes sense to have all of your ducks in a row. Basically, that's what it's about. Okay, so here's another try it for us. We have 2x to the third power plus 5x squared minus x plus 1. Okay, and then we're going to say, now, in this case, I don't have to write the 0x to the third power. I'm just going to put the bottom one on the bottom, which is going to be, usually, you don't even have to, in this case, I didn't even have to do that. You know, it's primarily when you have gaps. You could either leave a gap or you just have to keep in mind what, to be able to pass the gap. So like, for instance, if this didn't exist, I could have just not put that in there and just gapped over that spot. But it's convenient to put zeros. Now, so we're adding these two. We have 2x to the third power plus 5x squared minus x plus 1. And we have 2x squared minus 3x minus 4. So we're going to say negative 3, negative 4x plus 7x squared. And then we're going to carry down there. 2x to the third power. Check our try it. 1.4. Let's see here. 2x to the third. 7 minus. Yes, yes, yes. Okay, good. Everything's good. Find the sum. Okay, and now we're going to do subtracting polynomials. By the way, in linear algebra, we don't have subtraction. We multiply by -1 and we add it. But in this case, we are going to do subtracting. We're going to say 7x to the fourth power. Now, I'm going to do it like they did it in the book here. Again, I prefer using the method that I've been using from linear algebra, but this it doesn't really matter. I want to show you another way of doing it. And that's organizing like terms. That's what they're teaching us here. So if you're going to organize like terms, we're going to start by going 7x to the fourth power. And then we're going to say, we're going to carry, the negative is going to carry in here, and in here. So all the signs are going to get flipped. This is going to be negative, this is positive, this is negative now. So that's what's going on. All right, so we have 7x to the fourth power, and then we're going to say minus 5x to the third power, and then we're going to say minus x squared plus 2x squared. So here and here, we took those. And then I'm just working my way down from left to right, but also by stepwise. 6x from this side, from left now to the right, plus 3x, and then left plus 1 plus 2. Now you can see, you can totally do this. This is organizing like terms, but it's just more to keep track of. That's the only thing I should warn you about. Yeah. So let's just organize it. So we're going to have 7x to the fourth power minus 5x to the third power. And then, so when we combine the two, we're going to plus x squared. We lose the 2 and lose that one. And then we're going to have plus 9x plus 3. Okay? And check that real quick. Wait a minute. There is a mistake I made here. It's the 6 should be positive, but the 3 should be negative, and that is right. So like I said, this is why I prefer doing the linear algebra method, organizing them, because there's a lot to keep track of. This is that negative that I missed. So doing that, we end up with a 3x. There we go. All right, and we're going to find the difference now. We're going to go again. This time, we're going to, instead of organizing it this way, we're going to organize it top and bottom. Negative 7x to the third power minus 7x squared plus 6x minus 2. And then we're going to have minus 4. Now we're going to rewrite this. We're going to take a page out of our linear algebra book here. Minus x plus 7. But in case you keep listening to me harp on linear algebra, it's an advanced math, but it's we can take elements from there and use it here basically. So we're going to go like this: 7x to the third power minus 7x squared plus 6x minus 2. And I'm going to spread the negative, and we're going to do an addition instead. So we're going to multiply everything by -1, or think of the negative as being spread across there. So it's going to be plus negative 4x to the third power plus 6x squared plus x minus 7. Let's check to make sure I did that part right. Yes, 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 yes. Okay, and now we're just going to add them. So I spread the negative, and we're going to perform an addition. Negative 9 plus 7x, and then we're going to have minus x squared, and minus 11x to the third power. Check the work real fast. All right, and let's check the answer in the book. All right, this was our, is this a try? I think this was a try it. 1.4. Yeah, let's see, there it is. Okay, yeah, good, good. Yep, everything's right. Good. All right, and now we're going to do multiplying polynomials. Multiplying polynomials is a bit more challenging than adding and subtracting polynomials. We must use distributive property to multiply each term in the first polynomial by each term in the second polynomial. We then combine like terms. We can use a shortcut called FOIL method when multiplying binomials. Certain special products follow patterns that we can memorize and use instead of multiplying polynomials by hand each time. We'll look at a variety of ways to multiply polynomials. Multiplying polynomials using the distributive property. To multiply a number by a polynomial, we use the distributive property. The number must be distributed to each term of the polynomial. So, this distributive property. So a times b plus c is equal to ab plus ac. That's the distributive property. Okay? All right, so now that's basically it to that. Here we go. So we're going to find a product. We're going to say 2x plus 1 times 3x squared minus x plus 4. All right, so we're going to distribute this. So we're going to say 6x to, so we're going to go here, 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 and then we're going to go here, here, here. So this is going to be operation 1, this is going to be operation 2. Okay? So we're going to go with, let's see here. Let me think about this for a minute here. Or let me just think about this. What is going to be the more effective way of doing this? Or we can go AB. We can go about it that way. Go one by the other and then followed by the second one. Which, yeah, let's just do that. The other option is we can go one and the other. This is one way. Or we can do it like this. 1, 1. Then we can go 2, 2, 3, 3, right? I'm just thinking which way is going to give us the more practical appearance. All right, well, let's just go by, we're going to spread 2x times 3x squared. That's going to be 2x, 6x to the third power, and then minus 2x squared. And then we're going to say plus 8x. So, and then we're going to go with 3 plus 3x squared minus x plus 4. And then we just have to shift them around a little bit because they're not in order. So we're going to say 6x to the third power minus 2x squared. And then we're going to say plus 8x. And then the bottom portion, we're going to line it up with, we're going to say plus 3x squared minus x plus 4. Okay, and then we're going to go 6x to the third power. And then we're going to go with plus x squared minus 7x plus 4. Check that. Everything's fine except for that should be a plus 7x. Yeah. So right, the 8x minus 7x, that is correct now. Okay. So as you can see, the real danger isn't not understanding it. It's just, forgetting the proper sign or something like that, or mixing up the fraction. That's where the real danger is, making mistakes. Otherwise, it's pretty self-explanatory how this works. Let's go now with 3x plus 2 times x to the third power minus 4x squared plus 7. Okay. Check that, check that. Okay. We're going to say 3x to the fourth power minus 12x to the third power plus 21x. And then we're going to go with 6. No, we're just going to, we'll order it later. Let's do that first part. The second part, we're going to go with 6x to the third power minus 8x squared plus 14. And let's organize it, which is equal to 3x to the fourth power minus 12x to the third power plus 0x squared plus 21x. And in the bottom portion, we're going to have 6x to the third power minus 8x squared plus 0x plus 14. Okay, so notice that I organized it, put the zeros there. As long as I remember, as long as I don't write so sloppy that I can't read my own zeros, then it's fine, right? So we're going to have 3x to the fourth power minus 6x to the third power minus 8x squared plus 21x plus 14. Check my math real quick here. All right. Looks right to me. Now let me check. This was another one, right? As a try at number 4. Okay, so 3x to the fourth power, 21x, 14, negative 10x. So I made a mistake in the second. It should be negative 10x to the third power. So I did the math wrong. Let's find out where I messed this up. So this one was wrong, and that's because I see it's supposed to be 2 there. So again, the problem with these, the real danger, is that you end up blowing through them and the arithmetic gets mixed up. And that's a very common thing, by the way. It's not that you don't understand how this works. It's just that, the amount of time you spend on it, you end up, if you do a lot of them, you try and not make any mistakes, but you do make mistakes. And it's kind of like a function of how necessary is it for you to get the answer right versus covering the material, right? Like if I have time and I want to spend time to make sure that I don't get an answer wrong because I have to submit it for homework and get credit, then I'm obviously going to go a lot slower than in a stream like this where I'm just trying to cover material. And, at that point, like it's less important to me here whether or not I make a mistake as long as if I find a mistake, I can fix the mistake and explain how I made the mistake. That's totally acceptable to me. But if I was submitting homework, then I would go back and redo each question twice by just walking it out. Did I do this right or wrong? Those are the kind of things you want to be careful about. Okay, so using FOIL to multiply binomials. All right, we have ax plus b. A and b are constants. C is a constant, x plus d. These are constants. So what we have is we multiply, let's see here, first and last terms, a and this one here. And then we're going to have the last terms. Okay, and then we have our inner terms. And then we have our outer terms. Okay, so let's grab our out. Where do we want to start? Let's start with the first and last. So that's going to be ax times cx. Okay, and then we're going to say plus, let's take the b plus d. Actually, then we have first terms, and then we have our inner terms. So we have this term, and then we have ax times d. And then we have b is going to be plus, then we have our last terms. No, sorry, then we have our inner terms. So we have 1, then we have 2, then we have 3, and then we have 4. That's how it's doing this. And the 3 is going to be plus b plus c plus x plus b and d. Okay? And then, so of course, this is going to be a cx squared plus a dx plus bcx plus bd. Okay, so FOIL works like this. The way I would So ax plus b. Personally, I think of it as this way. I would prefer spreading it this ways and then that way. That just mentally makes it easier on me to spread it all. And generally, when you do it in linear algebra, when you multiply matrices, that's kind of how you do it too. But yeah, like you, as long as you understand what order you want to go about it, and just don't confuse yourself. That's the big thing. All right. So, let's see here. So the order of operation, yeah, and then we have, which the way I drew it on the bottom is basically FOIL, I suppose. So we have the first one is A and C, and the second one is going to be A and D, AX plus times D, and then we have the B times CX, and then B times D. So again, whichever diagram works best for your mind, doesn't matter. So let's do 2x minus 10 times 3x plus 3. So we're going to go with 2x times 3x. Then we're going to say plus 2x. Here, yeah, 2x plus 3x. And then we have 2x times 3. And then we have the bottom terms, which is going to be negative 10 times 3x, and then negative 10 times 3. Okay, and so yeah, and 10 times 3. First product, what are they doing here? So, let me check this real quick. So this is going to be 6x squared plus 6x. Oh, it's not. You gotta be kidding me. There's another typo? Okay, this is typo number 3. Seriously, okay. Look on page 45. The equation there is 2x minus 10 times 3x plus 3. But when you go into the examples, it is 2x minus 18 times 3x plus 3. So it's not a typo in the sense that, the order of operations is the same, the multiplication is done correctly, but now instead of multiplying the 2x minus 10, it's 2x minus 18. So that's what kind of threw me off when I went back and looked at it. I'm like, where are they getting the 18? Oh, they just put an 18 instead of a 10. So, I don't know. This is like too many typos for my liking. This is already 3, and we're only in chapter 1.4. But whatever. It doesn't matter as long as you're just aware that they swapped the 10 with an 18. So, whatever. So, we have negative 30x minus 30. So yeah, so basically, yeah, it's the same thing. The spread, whichever spread you like, however mentally you want to map it, it's the same thing. It's FOIL. Okay. Next, we have x plus 7 times 3x minus 5. Okay. And then okay. All right, let me just check myself here. Okay, right. So far, so good. Oh, let's multiply this out. This is a try it. So we have So we have 3x squared minus 5x, and then we have plus 7x, plus 21x, and then there's minus 35. By the way, notice how I offset it? That's another thing you can do, and that's because the degree of the polynomial, it drops down 1 because this is a degree of polynomial 1, and this is a degree of 0, where it's a constant. Because of that, then all of them are going to be less by a degree of polynomial. So I just offset it to line it up for easy addition. So we have 3x squared, and then that's going to be plus 16x minus 35. Check my math real quick here. 3x squared. Yes, 21x minus 35. Okay, let's check it out. Try it, section number 5. Try number 5. Yeah, okay, that's fine. That's correct. Okay. Get a drink real quick here. We're flying along on this chapter. Okay. Perfect trinomials. Certain binomial products have special forms. When a binomial is squared, the result is called a perfect square trinomial. We can find the square by multiplying the binomial by itself. However, there's a special form that each of these perfect squares takes. Memorizing the form squaring makes it much easier and faster. Let's look at this. So we have, okay, so here's what they're telling us. A plus b squared is equal to a squared plus 2ab plus b squared. That's what they're going to try to tell us. Yeah, that's basically it. So this is called the perfect square trinomial. So yeah, we have x plus 5 squared. So then that's the equivalent of saying x plus 5 times x plus 5. Okay? By the way, here's another fun one. If you have a plus b times a minus b, the result is going to be a squared plus b squared. And why is that? We have a times a is a squared. A times minus b is minus ba, and then b times a is ba, and then, I'm sorry, it's a squared minus b squared. It's minus b squared, like that. And then b times b is minus b squared. So that's another form that you can remember. Okay. All right. So real quick, if you have this, that decomposes to that. And the same thing, this decomposes to that. It goes back and forth. So we have x squared plus 5x plus 5x plus 25, x squared plus 10x plus 25. And we're going to say let b equal to 5 and a be equal to x. So taking our formula, a plus b, we know that a squared plus 2ab plus b squared. Let's just try that right now. We're going to say a is x, so it's going to be a squared plus 2a and b times 5x plus b squared, which is 5 squared. So then we have x squared plus 10x plus 25. You see how that works? If you know this form, then you can use that. It's very convenient. And now, let's do one with a negative, though. All right, so a squared plus 2ab plus b squared. So we're going to say this is if we have the form x plus a squared. Now, if we have this form, x minus 3 squared, right? We have this one. Well, we can still take that. We're going to say let a be equal to x and b equal to negative 3. So we're going to say x squared plus 2 times negative 3x plus negative 3 squared. So that gives us 9 minus 6x and then plus x squared. So it works. It doesn't matter if they're both negatives. It does the same thing. You just take this formula and then you plug them in and it'll work. So it's pretty cool. All right. So we can also do the reverse if we have this formula. Here we go. Expanding perfect squares. So we're going to say 3x minus 8 squared. So then we have this form here. So we're going to say let a be equal to 3x and b be equal to negative 8. Now it's a plus b. Okay, so here we go. Is a squared plus b squared, or which is a plus b squared. Actually, no. This is called the freshman's mistake. Can't do that. A plus b squared. A squared is not the same thing. So that is so frequently made. It's called the freshman's error. But yeah, this is the one that we want. So let's do it. So we've given our assignment. We're gonna say 3x squared plus 2 times 3x times negative 8 plus negative 8 squared, which is called limit. So we're squaring this, gives us 9x squared plus 6x times negative 8. We'll do that in a minute. Plus, and that's negative 8 times negative 8 plus 64. And then we're just going to go 9x squared plus, we're going to make that negative, minus 48x plus 64. So that is our expansion. Again, all we got to do is use the formula. Now, we could multiply it out, of course. We could, if we didn't want to do it that way, if you don't like the formula, just go 3x minus 8 times 3x minus 8. And then you just go use FOIL to do it that way. So that's fine. Either way is fine. Okay, let's expand. So we have 4x minus 1. Okay. Square it. We're going to expand this. We're going to say we have a plus b squared is equal to a squared plus 2ab plus b squared. Our perfect square formula. We're going to assign let a be equal to 4x, b be equal to negative 1. We're going to fill them in. We're going to say 4x squared plus 2 times 4x times minus 1 plus minus 1 squared. We're going to say 16x squared, and then we're going to multiply this out. It's going to be 8x negative 8x, and then plus 1. All right? Let's just check that real quick. That was a try it number 6. Try it number 6. Yep. All right, so far so good. Okay, difference of squares. Another special product is called the difference of squares, which occurs when we multiply a binomial by another binomial with the same terms, but the opposite sign. Oh, I already gave it to you. Yeah, difference of squares is this. A minus b times a plus b, which is going to be a squared minus b squared. Okay, that's the difference of squares formula. And we can see it right here. Let's say x minus 1 times x say plus 1 minus 1. Okay, so we're going to multiply it. First, we're going to do FOIL. We're going to spread it out. And then I'll do the same thing with plugging into the formula. So x times x is x squared minus x. And then we're going to say plus x. And then we're going to say minus 1 squared. No, no, we're just going to say minus 1. 1 times 1, we're just going to keep that as 1. Minus 1, by the way, minus 1 is the same thing as 1 squared. That's the same thing. Because 1 times 1 is 1. And 1 divided by 1. So 1 divided by 1 is also 1. Anyways. And of course, which is also this. And this is also 1 over 1. So all of these, I'm just going to get rid of the minus. So the properties of the number 1, just so you remember it back of your head, 1 is equal to 1 squared, the square root of 1, and 1 over 1. 1 divided by 1. And 1 times 1. This is all 1. And 1 to the power of 1. So, and also anything to the power of 0. Not related to this, but technically, if you had like n to the power of 0, it's equal to 1. And I'm getting off topic, but yeah, those are the properties of 1. But getting back to what we had here, we have x squared minus 1, which is the same thing as saying x squared minus 1 squared. Now, remember, the minus is not on the inside, it's on the outside, so we're still going to end up with 1. Now, let's plug and play here. We're going to say let a be x and b be minus 1. Hold on a minute. In this case, we're just going to make it b. We're not going to carry the negative. We're just going to say b1 because the difference of squares is difference between them. So as long as you have the minus and the plus and everything else is a and b, then it's fine. So yeah, if we plug and play, we're going to say it's going to be x squared minus 1 squared, which is the same thing as x squared minus 1. So yeah, everything is in agreement. And let's do another one. Let's do x plus 5, x minus 5. Okay? By the way, these formulas, if you don't memorize them, so look, if you're doing this for class, don't try to memorize the formulas so much. I would say it's more important to understand how it works, and then you can be able to reassemble it yourself. That's really the big way to get it, in my opinion. But let's give this a shot real quick here. We're going to say it's going to be x squared, and this is plus and minus, so x squared minus 5x plus 5x minus 25, which is x squared minus 25. This is 0. Or plugging them in is going to be x squared minus 5 squared, which is equal to x squared minus 25. Same thing. Okay, and yeah. Okay, and here's a Q&A they're asking us. Is there a special form for the sum of squares? No, the difference of squares occurs because opposite sides of the binomials cause the middle terms to disappear. There are no two binomials that multiply to equal a sum of squares. So this is a square. This is a sum of squares. But there's no binomial formula that's going to give you that. Okay? So it's because if you were to do this, that decomposes to a squared plus 2ab plus b squared. Now, that I guess if you had a 0 as the b, you could end up with an a squared plus b squared, for instance. if that was the case, let's say let a equal to 1 and b equal to 0, you're going to end up with 2 squared plus 2 times 2 times, it will be 1 squared plus 2 times 1 times 0 plus 0 squared. So you end up with 1 plus 0, which is 1. I mean, I guess it kind of holds, but then this disappears. So it's not really the case. You can't really create this formula, but this is what it decomposes to. All right, well, we have one more. And this is multiplying binomials resulting in a difference of squares. Let's do that real quick here. All right, so we have 9x plus 4. And then we have 9x minus 4. Okay, so let's multiply this out and see what we get with this. So this is a difference of squares, right? So all we got to do is we're going to say a squared plus b squared. I'm going to say a minus b. So recognize the form. And then we're going to say a plus b, which is a squared plus b squared. Recognize the form. Let a be 9x and b be 4. So then now we know our a's and b's, and we're going to just substitute them. So we're going to say 9x squared plus 4 squared, and that's going to be 81x squared plus 16. And let's just verify it by using FOIL. Okay, so we're going to multiply. That's going to be 9 times 9 is 81. X times x is x squared. And then we're going to have minus 36x plus 36x and minus 16. That's my only mistake here. That should be negative because the form results, and the error was right here. I wrote the wrong formula there, but that is the same thing. So this comes out to 81x squared minus 16. So as you can see, the results are the same. So then we have 2x plus 7 and then 2x minus 7. What is our form? We have a plus b and a minus b. I'm going to say let a be 2x and b be 7. So let's do that. The result is a squared minus b squared. So we're going to say 2x squared minus 7 squared is equal to 4x squared minus 49. And we're going to use FOIL. So we're going to have 4x squared minus 14x. And then we're going to have 14x minus 49. Comes out to 4x squared minus 49. All right, let's check that. (1.4). This is try it number 7. Section 1.4, try it number 7. 4x squared minus 49. Yep. All right. Let's see here. Okay, so, and then now we have performing operations with polynomials of several variables. Okay. So again, what we're going to do is a couple of things. So sometimes, like a lot of times, it's not so simple as the forms that we've been doing. Oftentimes, it's of multiple, something like this. A plus 2b, and then we have 4a minus b minus c. So in this case, we're going to use FOIL. We're going to distribute it. So we're going to go with, there's a couple ways to do it. We can go with 1, 2, 3. 4, 5, 6. Now we can write them all in order, one underneath the other, or we can go like this: a times 4a minus b minus c, and then we're going to say plus 2b, and then again 4a minus b minus c. So that's another way of distributing it. And that's going to be 4a squared minus ab minus ac plus 8ab minus 2b squared minus 2bc. And now we're going to add like terms. So in this case, we're going to say 4a squared, and then we're going to see it. Okay, so we have negative ab. We're going to make this a 7. We're going to say plus 7ab, and then we're going to have, there's no other ac, minus ac, and then we're going to say minus 2b squared minus 2bc, and let's organize them by size. There we go. And then by the degree of the polynomial is how we're organizing them. So we have the two squares in, and then we're going to say plus 7ab, and then we're going to say with minus ac minus 2bc. Okay. So that's going to be, okay, so the way, now I organized them by the size of the polynomial, but you don't have to do that. Like in this case, they didn't. They simply kept they just multiplied them out. You don't have to organize by degree of polynomial. I personally think that you should, but it's whatever. Okay, so now, next one we're going to do is going to be, let's try x plus 4 times 3x minus 2y plus 5. Okay, so we're going to do, again, we're going to just distribute it. So we're going to say, I'm going to go like this, with a 3x squared, and then minus 2xy, and then plus 5x. And then beneath that, we're going to say, so the closest one where I can find this, the 3x, is over here. So I'm just going to put it right there. I'm going to start 12x, and then we're going to say minus 8y plus 20. Okay, and I find that probably the easiest way to do it if you're doing a binomial by trinomial. All right, let me check the math real quick here. Let's see here. Minus 8y. Okay. All right, and minus 2xy plus 17 is 8y plus 20. Okay, yep, that's correct. Now we're going to do try it number 8. We're going to say 3x minus 1. We're going to say 2x plus 7y minus 9. Okay. All right, so let's do this. So we're going to say 6x squared plus 21xy minus 27x. And then, again, the closest one is the third one. That matches up, so that's going to be minus 2x minus 7y plus 9. By the way, the fact that it's the third one in the order that offsets has to do with the degree drop. There's a degree drop here, but also the way it works, because of the structure, offsetting it by 1 degree means the whole third is shunted over. So that's just the way it works. This is always going to be the case if the degree of the order is the same. So, which isn't to say that like these two, the x and the y, have the same degree of the polynomial. The x times y, I would argue, is of a higher degree because you're multiplying the two of them, even though technically they're both of the same degree. But I would go with first, I would use the degree of the polynomial, and then if it's the same degree, whenever you have the variables multiplying by each other, and then afterwards you work your way down to the constants. Single variables, and then finally the constants. All right, so then we have minus 29x minus 7y plus 9. All right, let's check that real quick. All right, seems to be right. Let me check this. 1.4 xy minus 29. Yes, okay. All right, well, we got through all the reading material. The next is the questions section. So I realized I didn't plug in my mic, so I don't know how badly all this sounds, but I'm going to stop the section here, and then I will see about doing the section as a part 2 of 1.4. All right, hope you had fun. I know I did.